Okay, we're going to go through the Unit 3 Expressions Study Guide. So starting off with identifying parts of an expression. So first of all, I like to just box up my terms, right? Train it up, choo, choo. So if I train that up, now I just broke it up into terms, which is awesome because the first question is terms. So each of those boxes is a term. So I'm just going to separate them by commas. So 2a, comma, 5b, comma, 4, comma, b, comma, 7. And then variables. Remember, your variable is the letter that stands for a number. So each letter I see is a variable. So I have A and I have B. There's another B. I just don't need to write it twice since it's the same letter. If you do, it's okay, but you don't need to. Coefficients. Coefficients are your co-pilot. So remember, your variable is your pilot. Every variable has a co-pilot. So every number that was being multiplied by a variable. So the 2 from 2a, the 5 from 5b, and then this regular b, remember it's got this invisible 1 here. So 1 is also a coefficient. Then you have your constants. Your constants, remember, are constantly alone. They're just the plain old numbers, no variables. So 4 and 7 are constants. And lastly is our like terms. So remember, these have the same last name, same variable raised to the same exponent. So I have 5b and b. Those two go together. Also, constants count as like terms. So 4 and 7 are also a set of like terms. All right, simplifying the expression by combining like terms. So again, we're going to start by training it up by boxing our terms. And then I'm going to use my commutative property to rearrange this and change the order so that I can put my families together. So I have 2a, there's my A family, and I just check them off as I go. So plus 5b, and there's a b that goes with it, so plus b, there's my B family, and then my constants, plus 4 and plus 7. And then I can go ahead and combine those. So 2a, there's nothing to combine it with, so it's just 2a, plus 5b, plus, remember this is an invisible 1b, so that is 6b. And then 4 plus 7 is 11. And that is my answer. I can't simplify that anymore. Then for our next one, same thing. So I'm going to box my terms. And I'm going to rearrange this using my commutative property. Remember, alphabetical order is normally how we go, and then if there's the same letter but different exponents, you go biggest exponent to smallest. So I'm going to have 4f squared plus 11f squared. There's my f squared family. That is separate from my f family, so 3f plus f. And then finally my constant 6. And let's simplify that. So 4 plus 11 is 15f squared plus 3f plus, remember this is an invisible 1, so 3 plus 1 is 4f. And my constant 6 just stays 6. And that's my answer for that one. Okay, so this addition problem, I can go ahead and box my terms. And actually, these are all the same. They're all m's, so this whole thing is one big family. And remember, when we're adding our terms, when we're combining them, we are really just adding the coefficients. So remember, these all have a 1 coefficient. So 1 plus 1 plus 1 plus 1 plus 1 is 5m. There are 5 m's. This next one, though, if you look at it, it's a little different. It's got multiplication in between. So remember, the easiest way to write a repeated multiplication problem where the same thing is being multiplied over and over is by using an exponent. So I'm going to have m to, let's see, 1, 2, 3, 4, 5. There's 5 of them. So to the 5th power, because I multiplied m times itself 5 times. All right, for this one, we have to combine like terms, but there's parentheses, so I cannot train it up yet. First thing I have to do is use my distributive property. So I'm going to distribute this 9 times 3, which is 27, plus 9 times 4, which is 36. Keep that last name, so 36W. And I have to bring down this plus 12W. Once I've done that, now I can train it up. Remember we say you hand out the tickets before you can get on the train. So we had to distribute that in, and then we could train it up. Now I can combine these like terms. So I really have, let's see, I have my constants, and then I have my W family. So 27 is just 27. 36 plus 12 is 48. Keep the last name W. And that is your answer. Okay, same idea for the next one. We're going to have to multiply this in. So 2a times 5a. Remember, you multiply the coefficients and then multiply the variables. So 2 times 5 is 10. A times a is a squared. And then 2a times 7b. 2 times 7 is 14. A times b is just ab. And then bring down this plus 6a to the second power. Now I can box my terms and combine these like terms. So I'm going to rewrite it. 10a squared plus 6a squared. There's a family. And then plus this 14ab. There's a family. And go ahead and combine them. So 10 plus 6 is 16a squared plus 14ab. And there's our answer for that problem. Okay, we're going to use the GCF to write an equivalent expression with distributive properties. So first thing we need to do is find the GCF for these two numbers. So I have 24 and 16. Do my t-charts. So 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's it. For 16, I have 1 times 16, 2 times 8, 3 doesn't work, 4 times 4, and that's it. So then I need to find my greatest common factor. So the greatest number they had in common was 8. And then to write it in distributive property, remember the number they had in common goes outside the parentheses, and whatever's left over goes inside. So 8 times what gave me this 24? It's right here, 8 times 3. Plus 8 times what gave me this 16k? Well, right here, it was 2. Don't forget the k, because 8 times 3 is 24, plus 8 times 2k is 16k. So that is my answer for that problem. Down to the next one. We changed this, remember, to say 25b. So sorry about that typo. Okay, so set up your two t-charts. I have 25 and I have 15. So 1 times 25 and 5 times 5 for that. 1 times 15 and 3 times 5 for that. So my greatest common factor is this 5. Remember, that's what goes outside my parentheses. And then 5 times what gave me 25? 5 times 5, keep the last name, B. 5 times what gave me the 15? 5 times 3, keep that last name, A squared. And that is your answer for that problem. All right, order of operations. We need to do our PEMDAS, parentheses, exponents. Remember, multiply, divide, left to right. Add, subtract, left to right. So starting with parentheses, inside of there I need to use order of operations. So I'm actually going to do this division first. So let me write everything else down. 6 divided by 2 gives me 3. I'm keeping those parentheses because I'm not done solving everything inside of there. So I still need to finish that off. So I have 7 minus 3, which is 4. Now I can get rid of my parentheses. Then next would be exponents. Remember, this is 4 times 4, which is 16. Okay, and then finally 16 times 4, which I'm going to do over here. See, that gives me 24, 64. So my answer is 64. All right, parentheses, no. Exponents, no. Multiply, divide, left to right. Remember, it has to go left to right, so I'm actually going to be doing this division first. So I have 25 minus 16 divided by 4 is 4. Bring everything else down. Then I can multiply. So 4 times 2 is 8. Bring everything else down. Add, subtract, left to right. So again, working my way across, subtract before I add because it's left to right. So 25 minus 8 is 17. And then finally 17 plus 9 gives me 26. Okay, parentheses. Notice this exponent's attached to the parentheses, so I have to solve what's inside first and then take that answer to the second power. So 5 plus 4 is 9. So I have 9 to the second power minus 17. Now I can do this. This, remember, is 9 times 9, which is 81, minus 17. So 81 minus 17, I'm going to have to borrow, and I get 64. Okay, now we can evaluate. Remember, when you evaluate, you need to substitute the numbers in and then solve with the order of operations. So I'm going to rewrite it first as 2 plus 5, parentheses, there's my exponent 2, minus 12. Okay, so solve here. I get 7 to the second power minus 12. 7 to the second power, remember, is 7 times 7, which is 49, minus 12. And then 49 minus 12 gives me 37 as my answer. When I look at the next problem, it's area of a rectangle, and that's okay. It doesn't really matter. It's still just LW, and they told you the L and they told you the W to substitute in. So this really says 3.3 times 4. So 3.3 times 4. 4 times 3 is 12. Carry my 1. 13, 1 decimal place, so 1 decimal place, so I'm getting 13.2. It is area though, so inches squared for my answer. And finally, our properties. So I have this first one. I'm just going to look and see what is changing from one side of the equal sign to the other. So here I can see 9 plus, in parentheses, 27 plus 13. On the other side, 9 plus, parentheses, 13 plus 27. So what the parentheses are around is not changing, but the order of the things inside of the parentheses, that's what's changing. Whenever the order changes, remember, that's commutative property. And this is of addition, so commutative property of addition, which is C. Next one, 15x times 1 equals 15x. So I started as a 15x, I ended as a 15x, so I kept the identity the same. I did that by multiplying by 1, so this is identity property of multiplication, which is F. Next, 77 times 25 is equal to 25 times 77. The order changed. So commutative property is when the order changes of multiplication this time, so D. 325m times 0 equals 0. Anytime we multiply by 0, we get 0. So this is your 0 property of multiplication, H. Next, D plus E are in parentheses, plus 8 on the outside, and then the D is on the outside and E plus 8 is on the inside. This is our love triangle. This is the order not changing, but what's inside the parentheses. The parentheses are changing. So who's being associated? This is associative property of addition, A. Next one, 93 plus 0 is 93. Our identity stayed the same by adding a 0. So this is E. It was adding a 0, so it's not 0 property of multiplication. Be really careful on that one. Next one, 2 times in parentheses 5 times 3, or on the other side, 2 times 5 in parentheses times 3 on the outside. Again, love triangle. This is where the parentheses is moving what's inside the parentheses, who they're associated with. That's what's changing. B, associative property of multiplication. And our last one is distributive, because look, 5 times 9, 5 times 4, it was subtraction there, it's subtraction here. This is G, distributive property. And that's it, guys.